Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at the date functions library and date handling. In many of your applications, you may well have to do date handling. You may be taking information from a user, from a file, from a database, or from some other source. Some of the data in these records may well contain dates, possibly a date of creation, a date when the record was updated, or possibly other dates. And today we're going to look at date handling, how we can use dates, and how we can manipulate them using the PowerBasic PowerTime object. So we're going to add today to our date functions library. So we've included that at the top of the code. So we're initially going to create two local variables to hold our dates, date 1 and date 2. And we're going to populate these two dates. The first date we're going to populate with the current UK date. PowerBasic does have a date $ command which you can use to pull back the current date. However, it pulls it back in a US format. So I've created a function in our dates library to convert that into a UK formatted date, as in day, month, year. If you're in the US or using the US date format, just use date $. So now that we have two dates populated, the question I want to ask is which date is larger? Is date 2 greater than the current date or not? So how could we actually determine that in code? The first thing to do is to double check to make sure that date 2 is indeed a valid date. Now we've already got a function in our date library that will perform that for us. And that is the isDateValid function. There's two variations on that function, one that takes the UK formatted date and one that takes the US formatted date. Just use whatever one is applicable to yourself. So now that we've determined that this date is valid, can we tell if date 2 is greater than date 1? So we're going to create a new function to perform that exercise for us, so that when you're actually coding these up in your own applications, it minimizes the amount of typing you have to do and keeps the code looking clean. So we're going to create a new function called dateNumber. There will be a UK and a US format of that. It takes a single parameter. In this case, we're passing it date 2, and we're calling it again and passing it date 1. And this function will return a large quad number. And the more recent the date, the larger that number will be. So determining whether one date is before or after another date is then down to simple arithmetic. So let's have a look at our code library for the dates and we'll create this new function. So we're going to create three new functions here. A dateNumber function, which will do most of the work, and two stub functions, one for dateNumber UK and one for dateNumber US. Each of these stub functions will actually call the dateNumber function, passing it the parameter of the date and the format, be it UK or US. So here is our dateNumber function. Two parameters as we said, the first being the date, the second being the format, either UK or US. So we'll create a PowerTime object first of all to hold our date. And we now want to split the date up into its year, month and day components. So we will create three local variables, year, month and day, all being longs, to hold that information. Now as we're going to be doing quite a lot of splitting up of dates, I'm going to create a custom function whose sole task in life is to split dates into these three components. We'll call that function splitDate. It will return a true or a false, a true if it has managed to split the date into those components, or a false if it has not. So we'll create that function in a moment, but let's continue from where we are. Let's assume the date has now been successfully split up into its three component parts. Now we'll use the object we created, the PowerTime object, to populate the date. We'll do that by using the newDate. The name of the object .newDate, and the three parameters being the year, the month and the day. If that result is okay, then we can then return the file time of the object. that is a large quad number which we're going to pass back and allow the arithmetic in our main code module to actually work out which date is the larger. So all we need to do now is to write the split date function. Our split date function is going to take a number of parameters: the date, the format, UK or US, and 3 output parameters being the year, the month, and the day. So this is going to be quite straightforward. We're just going to use a select statement to work out which format we have, and we will then use the right, mid, and left dollar strings to actually slice up the date into our year, our month, and the day. If any other format comes in, we will pass back false. You can always extend this function if there are other date formats you wish to handle. So now that we have that in place, we'll put in the 2 stub functions now. One for date number UK and one for date number US. They take the single parameter, strdate, and they call date number passing on that variable and a hard-coded either UK or US. So now that we put the code into our date functions library, let's see if it will run. Now we've populated these 2 date variables, one with the current date in UK format and one with a date which is the 25th of December. At the time of recording this video, our current date is the 20th of November. So as this is the case, our date 2 should be greater than date 1. Let's run the code and see what we get. And it does indeed tell us that date 2 is greater than date 1. Let's change the dates and see what we get. If we move the date back to the 25th of the 10th and run our code now, we'll see that date 2 is not greater than date 1. So we've now found a very straightforward and easy way of working out if dates are before or after another date. Another common activity when doing date handling is determining whether a date is within a certain period or not. For example, is this date this week, this month, this quarter? So a standard function to work out whether a date is within a certain period would be useful to have. So we're going to prep for a third date now, and we're going to populate our 3 dates. Date 1 is going to be the 1st of December, date 2 is the 1st of November, and date 3 is the 28th of February 2022. So we're wanting to determine whether date 1 is within this period or not. So we're going to create another new function called dateInPeriod. This is going to follow the same kind of logic as we had before. We're going to create a dateInPeriod function and 2 stubs, one for UK and one for US. It will take 3 parameters: the date we're interested in and the start and end dates of the period. So let's go back to our date functions library and add this new function in. So as before, there are actually going to be 3 functions: the dateInPeriod function and 2 stub functions, one for the UK and one for the US. So here is our dateInPeriod function, taking the 4 parameters: the date, the period start date, the period end date, and the format, be it UK or US. So we're going to need 3 PowerTime objects here, one for the date, one for the start date of the period, and one for the end date of the period. So there are our 3 PowerTime objects. And again, we need to actually handle these and split them up into their components of year, month, and day. So we'll need variables to handle that. And we're going to turn each of these dates into a quad number. So we will prepare 3 quad variables to hold that information. So as we already have created a dateNumber function to turn a date into a quad number, we can reuse that in this piece of code. So having set all our variables up, we're going to use the funDateNumber function to return the quad value of each of these dates. The quad value of the date we're interested in, and the quad value of the start and the end dates of the period. And then a simple line of code to determine that none of these quad variables have actually got the value 0 in them, which if they did have the value 0, then something has gone wrong with turning the date into a quad. And once all 3 of these are non-zero, So then we can do a simple piece of arithmetic to work out if the date is greater than or equal to the start date and less than or equal to the end date, returning true if that's the case and false if it is not. So as we did before, we will also create these stub functions, one for the date in period UK and one for the date in period US. So if we run the code as it stands, we should see if date 1, which is the 1st of December, is within these two dates, the 1st of November and the 28th of February 2022. And that does tell us that this date is indeed within this period. If we then change the start date to be August and then run again, this should tell us that this is not within, which it does. 1st of August is not within the period in question. So we now have an easy way of taking one date and discovering if it's in within a particular period. This could be a month, a quarter, or any two arbitrary dates. So what other date handling can we do with these functions that would be useful in your own code? Occasionally you may want to work out how long a period is in days, from a start to an end. So we're going to create another function to work out the period length in days. So we're going to create a new function called period length. Again, as before, there will be two stubs, one for UK and one for US. And we're giving it these two dates, date 2 and date 3. So we're going to work out the number of days between the 1st of November and the 28th of February, which is roughly 3 months. So back to our date functions library. So as we've done before, we're going to create three functions, a period length function and two stub functions, one for the UK format and one for the US format. So just as we did before, we'll create a new function with three parameters, a period start, a period end, and a format. As we have two dates handling here, we'll create two PowerTime objects. And we'll need a variable to determine the number of days, and also one for the sign, be it positive or minus, depending which way round your dates are. We're going to be splitting this up again, as we did before, into the year, month and day components. So we'll need those variables as well. And we will reuse our split date function to take the period start, the format, and split it into the year, month and day, which are then used with the new date to put it into our PowerTime variable. And we will do exactly the same for the period end. And once that is in place, we're going to use the timeDiff method. This will then take our end date object, our start date object, and it will return the length in days plus the sign, either positive or minus. And the return of our function is merely the sign multiplied by the length in days. So we'll need our two stub functions, as we did before, doing exactly the same as the previous ones did, passing either the UK or the US as the format. So we try running that now, we should get around 120 days as a result. 119 days for the period length in days. So we now have a method by which we can take two dates and return the number of days between those two dates. Hopefully you'll find all these functions useful in your date handling. That's it for today. Thank you for watching.